this stuff around the classroom. I have graph paper spread out like as many places as I can. Staplers are all bad for you actually. Staplers over here, but I'm probably going to bring another shelf here later today and stick it up here with graph paper, staplers, that sort of stuff. We can't really use the counters like normal because, actually I'm probably going to shift the whole middle rows. Not today, but I might ask that you guys sit either up here or over there so that we can access the counters if we need to like use those during class because we're going to be here for like 5 months. Oh, hey, if you're trying to staple that much, this stapler does more, like does it thicker. And if not, we might have to have you ask the meeting specialist. Do you have a binder for this?
Yeah.
Well, because our holes in one is what I'm saying.
I put it in a folder.
You are stapling.
Can I also use that?
Okay. So I will leave a stapler up there. And our plan book's falling apart, guys. So the cubbies over there. Next week, I'm going to be collecting and checking your math, whatever. So notebook or binder or stack of graph paper, like whatever notes you have been taking, thank you. I'm going to be collecting those next week. So if you need to reset and like start taking notes better again, do that, right? Do that today. So everybody should get out a piece of graph paper and something to write with. And our header today is still going to be proportional relationships, but we're going to get into proportions. So go ahead and head your paper solving proportions. Turn our paper solving proportions. Yeah, sorry that I'm going to throw a test at you so soon after coming back to school, but next week we are, like I'm just saying this again to make sure people heard me, we are going to take the unit test probably next week, probably for you guys Thursday, I would guess. But that's likely going to be a paper pencil test, right? So when we take that is when I will collect your math notebook or whatever. So that also probably might mean, hint, hint, cough, cough, that it might be an open note test because then you would turn your notes in after the test, cough, cough, nudge, nudge. So you might want to make sure that you take good notes, especially today. What's today's date? 11221. All right, so we talked about these last week, I think, but I need one of you to tell me. Did we talk about these problems with the lemonade and the sugar and then the ripped off? This is kind of a rip off.
No, we didn't.
We did not. Okay, let's write these tables starting with the one on the left. So I'm going to go ahead and cover up the one on the right. If we are making lemonade and we're comparing how many cups of sugar we need to how much final lemonade we get. So you can just label this sugar. No one's going to join me. Sugar and lemonade. We have 1/3 relates to 1 cup of lemonade. 1 cup sugar relates to 3 cups lemonade. 3 cups sugar relates to 9 cups lemonade. So before we can solve a proportion, we must first check that it is a proportion. So leave a little bit of space beneath this. We're going to say to check proportional. There are 2 things we have to check. And guys, if we did this, you might remember that these are the 2 things we wrote down. I don't know that our class made it to this. Is there a constant of proportionality? And constant of proportionality goes from the x to the y. Remember, is there a constant of proportionality that is the same throughout. I'm not 100% sure if that's how you spell throughout.
You spelled it right.
And guys, if you can't read my handwriting or anything, especially my gents in the back, tell me. I can, on what I'm writing, zoom in on things. So to check proportionality, we need to make sure the constant of proportionality is the same throughout. And on the outside, see, this will make sense in a minute after we look at it. On the outside, if I go from a little x to a bigger X, that same number that we multiply should be true for little y to big Y. Man, I should have color coded this. I forgot about that. So let's say this, we're going to check in purple. So is our constant of proportionality the same throughout? Go back to our table. Remember, constant of proportionality goes from x to y. How do I go from 1/3 to 1? And draw all this on your notes, please. What multiplication here? Times 3, right? How do we go from 1 to 3? Times 3. How do we go from 3 to 9? Times 3. Sweet. So the constant of proportionality is 3. We can put a check next to this because it passed. Right? If we're checking, is this table proportional? This passed. Then, let's check our outside multiplication, which actually this is, what we're checking here is the scaling of if I scale x up or if I scale y up. So like this multiplication out here is actually a times 9, and that is the same on bottom, times 9. If I just go from the first x to the second x, this is times 3. That's a different 3 than our constant of proportionality. They just so happen to have the same number. But our scaling is checking from a smaller x to a bigger x, which is why I'm looking at the times 9, going from the beginning to the end. And then you check, does the smaller y and the bigger y do the same thing? So I want you to check the proportionality and chat about this with a neighbor, right? Once you have a decision, chat with a neighbor about it. This table for Jace's earnings. So if we want to make this table easy, just put hours and earnings, right? So when we make this table, we're just going to put out. Sorry, does anyone still need this table? I can leave this up on the screen. For the next table, just do hours and earnings. And then chat with each other. What do you think? If you get paid $20 for 1 hour of work, $30 for 2 hours, and $40 for 3 hours, is that proportional? Does it pass both of those tests that we talked about? Really what we're asking is this pay structure fair? If this is you, not Jace, if this is you earning this money, like let's say I'm hiring you to come rake my leaves. Let's say I'm hiring you to come rake my leaves. Is this fair? Chat with each other. Charlie, what are you thinking? No, why not? Yeah, this might be an easier question to answer. What should you get paid? If I hire you you rake my leaves, and I pay you $20 for the first hour, I'll hop over to Drew. Drew, what should I pay you for 3 hours? Yeah, this should be 60. So you guys, check this out. If we look at the multiplication, this is times 20 because I paid $20 an hour. But this would only be times 15, and this would be times something else. It's like 12 point something. I'm just going to put a question mark. So our constant of proportionality here fails because it changes. Please make sure we're writing this down. I'm going to be checking your notes next week. This is your last friendly reminder. Your notes are going to turn into a mastery assignment, by the way. Just like, essentially, if you take the notes and can turn them in, that's mastery. Like, if you have them well organized enough. I'm not looking for beautiful stuff or amazing pictures. Yeah.
What if at first we were writing it in like a notebook or something for like the first week of school?
Sorry.
And then we switched to this?
Yeah, so I'm not going to check way back into quarter one. I'm just checking like right now. So essentially, whatever's recent. I just want to see whatever you have. So whatever you have to turn in, even if it's only like 5 pages, because it maybe you forgot and you just really started now taking good notes again, trying to give you guys a way out. You just got to show me that you are taking notes, you're putting a header on, you're putting a date on. I'm just checking, are we doing, at least most of what we're supposed to be doing.
Are you like taking our notes or are you going to do the test?
So I'll probably collect them and give them back to you the next school day. But it's going to be after the test, so you shouldn't need them while I have them. Yeah, you could. You could like clip them together, like paper clip or binder clip or something. But I'm going to give you guys all a spot over in those cubbies, and we'll use that to like drop things back and forth to each other. So like you'll just set it over there, and then when it's back in there, you'll know it's graded and ready to be picked up. And honestly, I will probably just sit at the cubbies and like check it, put it back, check it, put it back. Yeah, so I tripled the amount of time worked, only doubled the amount of pay. That's a ripoff. Don't like that. Try this. Once you have your thought, talk to your neighbor. Go ahead and throw this in your notes, but real quick table. Let's just even say X and Y. Right? And you can say age and height if you want. But when we talk about these things, really age is acting like our X. And height is acting like our Y. 3 goes to 12, 7 goes to 35, and goes to 60. What do you guys think? Turn to a neighbor and discuss.
It's like 35 times 4. 4 divided by 7 is 5.
So you guys can probably figure this out pretty quickly. I'm going to pick on people that seem to be avoiding participation. So Skylar, do you think this is proportional or not? No, why not?
Because it's multiplied like 3 to get to 12 is times 4, and then 10 to get to 6 is 6, and then 7 to 35 is 5.
Yeah, so this fails also. So what we know is both of these, sorry, we should have written it up here, are not proportional. So that's what you want to write for both of these, is that they are not proportional. Any last questions on is something proportional or not? Checking tables. What about, have you seen something like this in your practice work? I have a trick. Now, I don't like when we like say trick for math, because trick makes it sound like you're like doing something tricky. You know what I mean? And so math tricks are not really like tricks. I have like a shortcut way to make life easier here. Go ahead and write this table down. It's just X and Y. So no heavy labeling to do. Go ahead and write this table down. The top, each number is divided by 6. So it's 5 over 6, 25 over 6, and 125 over 6. Then the Y values are 2, 10, and 50. We can, because every x value is divided by 6, we can temporarily ignore the 6. Absolutely. So, yeah, by the way, pencil sharpeners over there, because I 100% forgot to announce things like that. So, we can, I was looking for the version, I had one that's like all highlighted in a very particular manner. We can actually just look at those numbers, like 5, 25, and 125. So I want you to take a moment and analyze that table, ignoring the 6s. If you ignore the 6s, do you think the table is proportional? And then turn to a neighbor and chat about it. This one's kind of tricky. If we ignore the 6, guys, and I think it's Miriam that I hear doing this. If we compare the values, you can either do 5 divided by 2 or really 2 divided by 5. We normally do y divided by x. So ask yourself, what is y divided by x? Okay, so 2 divided by 5, that's 0.4, right? If we do that in a calculator. And guys, if you don't have a calculator with you, please bring one next week. I don't know where mine went to. They're in a box in the gym somewhere. So I've got some, but not a lot. Please bring your calculators to school next week. Like, put it in your backpack tonight so you remember it next week. So I'll get 0.4. If I look at the 10 and the 25, what's 10 divided by 25? Is it also 0.4? Yeah. And 50y divided by x. Again, ignore the 6 we can for a moment because they all divide by 6. This, 0.4, I think. Check it. If all of these have the same value, that's the constant of proportionality. Yep. So the constant of proportionality checks out, actually. Now check the outside of the table. How do I go from 5 to 25? Times 5. Is this also times 5? Yeah. How do I go from 25 to 125? Times 5. And this is times 5 as well. So it works. The scaling checks out too. They were quintupling, if you want to know what that's actually called. When you multiply something by 5, you are quintupling. All right, so now that we wrapped up our checking proportions, what about a word problem? All right, so read this carefully and then turn to a neighbor and discuss, do you think this is proportional? I'm actually going to write on the screen. You guys are like allowed to talk to each other. What? Ooh, we've got both answers. Discuss. It is. This is proportional because we never buy the popcorn. Like, we want to talk about what the price will be. Let's say I'm going to take us to the movies. I'm not. But let's say I'm going to take us to the movies. The price will be $10.50 times the number of tickets. Right? That is proportional. However, if we added on extra stuff like popcorn, it would not be proportional. So since we never buy the popcorn, it is proportional. Try this one. I know I gotta clear my ink. Good morning. Grab a seat wherever's open. I forget how to clear my ink. There we go. Try this. Anna's training for triathlon. Chat with each other when you think you know. This Tuesday and then next Tuesday, which is weird because normally we talk about this. We're really just reviewing, we've been reviewing the previous stuff about proportional relationships. We're about to do new stuff. Yeah. Anyone else want some more graph paper while I'm walking around? Cool. I got tons of it. I don't literally have tons of it, but I figuratively have tons of it.
Well, we've seen your graph paper, but maybe it is.
See, saying I have tons of graph paper is a hyperbole, which you're going to learn about in language arts today. Miriam, go ahead and tell us.
It is not proportional.
Why?
Because, like, as you keep going, if it gets longer and longer, then it wouldn't be exact. It'd be like, maybe it's 2 seconds at first, then it's 5 seconds, then maybe
That's my thing.
4.
Yeah, if it takes longer, if something changes, like the extra popcorn, if something changes, it's not proportional. So there's extra time, right? It did take 2 seconds per, but then we added on extra time as we got tired. Go ahead and write down both of these. Actually, never mind, don't do that yet. I'm really good at changing my mind. Then again, maybe I'm not. See what I did there? I changed my mind. Alright, so I want you to write down the word proportions. Anyone remember what a proportion is? We've been talking about proportional relationships, but what is a proportion? I can't hear you, but yeah, you're right. We need more than that, though. It deals with parts of things. A proportion is a fraction equal to a fraction. So if we think about my favorite thing in the world, okay, maybe my wife would be my favorite thing in the world, but pretty close up there, pizza, right? Pretty close up there with my wife is pizza. So if I had a pizza and I cut it in half, my wife would be like, Micah, you can't just eat half a pizza. And I'd be like, watch me, I can eat half a pizza. She'd be like, no, you gotta cut it into more slices. So I want to eat half the pizza, but my wife thinks it's a bad idea to just like nom on this giant piece of pizza. So I cut it again. And I say, look, I'm still gonna eat half the pizza, but now that means I'm going to eat 2 out of 4. And she's like, Micah, look, these pieces are the size of your hand. Like, cut it again. Fine, I cut it again. But I'm still going to eat half the pizza. which means how much am I going to eat now? 4 out of 8. Right? So a proportion is seriously just a fraction equal to a fraction. Now, why do we use proportions? We use proportions and proportional thinking to be able to solve, okay, if I keep cutting the pizza and I end up with 24 total slices, how many am I going to eat? 12. Because that's proportional thinking. And that's why we use proportions. Now, proportions work in a very interesting way. Exactly what we were just talking about with checking the tables, that happens in proportions. And what I mean is going from the x to the y, which I think I had been writing in purple. Like from 1 to 2, that's a times 2. That's a times 2, right? We get that x to y, that constant of proportionality. Or if you go the other way, right, the top is 1/2 of the bottom. But also, if we look outside the table, this would be the same as this. So since this is times 3, we know that this is times 3. So guys, proportions share those two aspects. I hope you're writing this down. I'm not asking you to write a lot. I'm asking you to just draw some arrows. From the x to y, from like the top to the bottom, or bottom to top, you can turn it around and go the other direction. That relationship has to be the same, and so does the outside. If we look at the outside, like going from bottom to bottom, will be the same as top to top. Now, the other thing that we need to know about proportions, but we won't use for a second, like we'll use this in a minute, is that cross products, I want you to write this now so we don't have to skip space for it. Cross products are equal. And what I mean by cross products are equal, I'm going to set up our original proportion again. 1/2 is, actually I'm going to do 1/2 is equal to 4 over 8. I'm going to pull this first fraction and the third fraction we used. If we look at the cross products, that means we go diagonal, and product means we do what? Multiply. So if I look diagonally here, what is 2 times 4? Is it the same thing as 1 times 8? You betcha. Cross products are equal to each other. So if you have a proportion, we know that we have equal cross products. This, some of you, and guys, I don't care if you write this or not, some of you have heard this called something like a butterfly method. And if you're like, what butterfly method? It's because if we draw circles, it kind of looks like the wings of a butterfly. Because if I make the little body, and I give it some antenna, cute little face, it's a happy butterfly. Yeah, so if that helps, it's sometimes called the butterfly method. Now we will come back to our cross products when we need to use that. These first couple proportions will not need cross products. So now write down those two proportions up on the screen. The 10/3 equals k over 9. Go ahead and try to solve this on your own. See if you can utilize what we wrote down up here, kind of looking for the same sort of thing. Is going from 10 to 3 or like 3 to 10, is either of those easy? Not really, right? What we're looking for is the easy option. And I will say these are actually nice. If you want to make a little note that these are actually nice. Not because of this. Who can tell me why I'm saying this one is nice? Go ahead. Not I can choose a number. Madeline, I'll give you another chance here. Can you tell me what happens here? From 3 to 9, what needs to happen? Times 3. And because I told you this is a proportion, it is equal, the same thing has to happen on top, making K 30. Because what happens on the bottom has to happen on the top. Now, this is the same over here, the purple arrow. It's just not easy math, right? That's a little bit tricky to get from 3 to 10. Same thing with 3 and 5. It's not terrible, but since it's a little tricky to get from 3 to 5 or 5 to 3, try this on your own. How do we solve for Q? Sorry, my Q looks a little funky here. If this isn't easy from top to bottom, ask yourself about the outside. All right, everybody / anybody, what's the multiplication here? Times 2. So if that multiplies by 2, we have to do the same on top. And what does Q become? Careful, 6. Now, anytime we're working with proportions, you always want to ask yourself, does my answer make sense? If I accidentally got like 20 up here, it wouldn't make sense for the top to be bigger than the bottom. What's up? Can I help? Or you good? You good? Okay. Did you? Yeah, I'm wondering if you accidentally got 6 in your head and then multiplied by 3 with that. But notice that, so on the outside, what we could write, like if we're making notes, is this is like not easy. It's not bad, but it's not easy to go from 3 to 5 or 5 to 3. So instead we look at the outside. The outside is a times 2 relationship going from left to right. So we have to do the same thing going from left to right. Is this feeling okay? Do you think we can do this? Any questions about this before we try another one on your own? Try this. My question for you is going to be, why is this one different? So 5 to 12 or 12 to 5, whatever you want to say, it's not very nice, right? Going from top to bottom or bottom to top. So look at the outside. What do we see on the outside? Who can tell me? Drew, go ahead. Yeah, this would be 3, right? To go from 4 to 12. All right, sweet. So we know we just... Crap. I can't times 3 because I don't know what this is. So if we want to go the other direction, guys, please make sure this is in your notes. We have to instead divide by 3. So because instead of going left to right, which we were able to find its multiplication, we have to go right to left, so we have to do division. Meaning that Z is 5 divided by 3. which if we make it a decimal is 1.6 repeating, so we probably won't. We'll probably just keep it as 5/3. Questions on that one? Why we had to divide instead of multiply? And guys, this is one of those skills where just the best way to learn it is just practice it. Do your Khan Academy practice. If you still feel iffy, do it again. Like, you can do those practices multiple times. Man, anyone ever get like a part of a song stuck in your head? That's. If I say Alanis Morissette, do you even know who that is? She's got this song about Isn't It Ironic? And there's this part where she goes, it's like rain on your wedding day. I know I can't sing falsetto very well, but that is just stuck in my head over and over. So just know that that's going on inside my head right now. There's a woman singing very high pitched. Like, guys, I'm trying to make your days interesting. I know it's lame that we all have to wear masks, but I'm happy that we're back at school together. So I'm trying to make things more fun than they could be. Man, this one's not nice in any way at all. Right? If we look at the outside of the table, is it nice to go from 7 to 8 or 8 to 7? Not according to me. This isn't terrible. Anyone know how we could go from 8 to 12? Yeah, what's that get you? Yeah, this would be 1.5. But, what if that didn't work? Like, what if this was 13? And this was like super duper gross? Let's apply the cross product equivalent rule. So, stick with me. You might want to watch before you write. And actually, guys, if you don't have any way to color code things, try to get some color code options like colored pencils or highlighters or even pens, but pens are a bit dangerous. Our first cross product is 8 times k. Excuse me. And by first, I mean just the first one we did. I like to do the one involving the variable first to put it on the left-hand side. And I'll show you why in just a second. Dang it. That really looks like a decimal. That's a multiplication. So we get 8k is equal to, what's 7 times 12? 70 plus 7 times 2 is 14, so we get 84. Break it up, right? 7 times 10 and 7 times 2. How do I undo multiplication in order to get the variable by itself? What's the opposite of multiplication? Division. So to get rid of this multiplication, we want to divide. And k, whoever's got a calculator, 80 divided by 8 would be 10. So then it's going to be 10 and 4/8. Or that reduces to, 10.5 if you want to make it a decimal. Alright, so here is where, and if you ask your parents or a sibling for help, they're going to say, oh, you want to cross, and they're not going to say products, they're going to say you want to cross multiply. So please write down cross multiply in your notes. We're going to go over what that process is. Step 1 that we did right here is to make equal cross products. So we multiply the diagonal terms equal cross products. Then we use inverse operations to isolate. So isolate variable. How do we do that? We use inverse ops. And that was us dividing by 8. Remember, that gets us a giant 1. Right? You guys all love the giant 1. Yeah, I saw you look up, Victor. You're like, yeah, woo, giant 1. All right, try this bottom one on your own where we solve for n. I'm going to have to flip pages, so I'm going to leave this for a second before I do. All right. Everyone good on the notes that are up there that I can flip pages? Guys, please make sure that we're not sitting here just like waiting for the math to be done. You need to try it on your own. So if you're sitting there not even attempting to solve for n, you are just selling yourself short. It's not horrible to try to go from 5 to 8 or 8 to 5, but still, let's try that cross product technique. So like I said, I take the variable 1 first. So what do we get when we multiply there? 8n, right? Because there's nothing to really multiply. And that'll be equal to, what's 8n equal to? What'd you get? Yeah, 11 times 5, so it's 55, right? What number do we want to get rid of so n can be alone? 8. So we divide by 8. What'd you get? 6.875. So honestly, we could leave it as 55/8, or we could write it as 6.875 if you really like decimals. Guys, I used to really, really, really like decimals. I don't know what happened that I decided I didn't anymore, but that's where I am. The last thing I want to show you really quickly, because I am like 100% out of time, is that when we go to build our own proportion, and this will be in the video if you want to look back at it, when we go to build our own proportion, let's say that I gave you a situation like this. 4 glue sticks cost $7.76. How much would 13 cost? Especially if you're working with a partner. There are 4 different ways to set up a proportion. We could go money over glue sticks equal to money over glue sticks. We could go glue sticks over money, just flip these fractions over. You could go the little value over the big value. So the little amount of glue sticks over the big amount of glue sticks. Little amount of money over big amount of money. Or you could flip that and go big over little. We will pick this up next time. If you really want to see, actually I don't know if I made it through that problem in any class. I think this is where I got cut off in each class. So we will pick that up. And by the end of the week next week, you guys will be ready to take a test on solving proportions. Right? Like, I think most of you are probably pretty close to ready right now because it's not much of a stretch from what we've been doing. So thank you guys very much. Please grab a wipe from up here at the seat. I'll just let you guys do it. Wipe your desk. The trash can is by the door on purpose with the hand sanitizer. So if you want to get a hit of that on your way out, please do that as well. I feel like a doctor when I do that. You know how doctors, every time they enter the room and exit the room, their hands, like, it makes me feel like a doctor. I don't know.
And also in between the visit, they use it like a million.
Yeah, exactly. Like, every time they touch you, they, like, then hand sanitize. Have a wonderful day, guys. Please ask questions. If you need to know where anything is or have any questions, please just ask us. Miss Allie's right on the other side of this wall. Unfortunately, we cannot open the wall now.